Hi everyone, I'm Tipatat. I am your MC for today. Again, please come. Don't sit on the edges. Come inside. Come closer. Let's make this a nice, comfortable crowd. I wanted to introduce Philip Rosedale. There's no one more qualified to talk about what is the metaverse than the man who actually created it with Second Life. And now he's taking all of his learnings from that, rebuilding what the true metaverse is going to be with high fidelity. It's something they've been working on for over 2 years. The public alpha just went live 2 weeks ago. I got to preview it. It is amazing. One of the most powerful experiences I've done in VR, and I've seen probably at this point over 1,000 demos, so that's saying a lot. So please, everyone, give a big round of applause to Philip Rosedale.
Thank you. Thank you.
Yeah, such an honor.
For that warm welcome. I got it. Oh, you can hear me. Ooh, and it's bright. The little face tracker is going to work here. So what is the metaverse? You know, I talk about that a lot. We obviously think about it a lot here at High Fidelity, and I've done a lot of slide presentations, but we've actually gotten so much done in the last couple of weeks that I thought what I'd do, and this is a perfect size crowd, we'll do this and then take some questions and talk about it. We have been working for the last week or so putting together the best live demo of everything we can show you in high fidelity, and I hope everything about the metaverse. And so we're going to just do that right now. So you can see I am live. I'm going to turn my little face camera on. We're going to talk about that later. One of the really cool things. Let me see. These are bright lights. We'll see if it works here. Well, it's kind of working. Yeah. I'll show you more about that in a second. So, yeah, what is the metaverse? Well, I'm going to talk today about what I think it is, hit a bunch of points and kind of show you each one of them. You know, the first one is that as we build these 3D worlds, you know, the metaverse has to be something that contains the web itself. This ability to basically browse a web page, which we just got working. You can see I can literally walk up to this thing and, you know, go through my... Go through my, this is like one of those SlideShare presenters. Go through my slide deck on here. Where's the next one there? We're just getting this working. Yeah, see these little arrows work too, but we've got a web entity. I think it'll come up in a second. We're also doing this entire demonstration live with 3 of us, you'll see in a minute, over my iPhone. Out over instead of the show network, because this actually has a little better performance. But partly this is going to show you how fast the internet has gotten and how stable everything can be. So browsing the web is a part of the metaverse. Not only do we need to have 3D worlds, but we've got to be able to, you know, read email and surf the web and do everything, build essentially on top of the layer that came before us. And that's a fun piece of it that we just got working. So not only can you put web pages on easels like that, but I can, as we'll show you a bit more later, I can pick that, you know, I can pick that web page up. I can point at it in world, right? My avatar can point with a laser pointer all the time, which is something we can't do in real life. And I can also pick that thing up and throw it across the landscape. Over here in the distance, you can see this is a beautiful set that we've got working now. This is some brand new content that we're just about to start releasing for people to be able to edit and work with. You can say hi to Ryan and to Chris here. They're going to be back in a minute. Chris is on this side in an Oculus DK2. Ryan is here using, and we're going to see a lot more of that in a minute, the 2D camera that we have now built into high fidelity that can track your body movement, just like the HMD, and also your face. So, you know, what is the metaverse? So the metaverse is 3D spaces, but what else does it mean? That's what I want to talk about today. So first of all, it's got to contain the web. You need to be able to read your email in it. I do believe that that's a compelling idea, as crazy as it seems. One of the things I realized the other day was that when you're in the HMD and you're looking at a web page in a virtual world, guess what you can do? You can lean closer to it to see it better. And think about that for a minute. That's just one of these little fascinating discoveries. What happens then is that the number of pixels on that web page goes up as you lean in, because the HMD essentially is tied to your head. So as you bring it closer, it does get better. When you lean in closer to your computer screen at home, as we all know, nothing happens. The number of pixels that the web page content covers doesn't change. So there's all these amazing things that are going to be fascinating. But the metaverse is about bringing the web in as well. The metaverse is also about editability. This is a beautiful scene, but it doesn't mean anything. Oh, hold on, I just screwed up with one thing there. Let me turn off my full screen here for a second. Oop, wait. This is one of those party fouls with our stuff because I basically just, what did I do, guys? I gotta resize that little window there. Hang on a second here. Turning off my tool window. There we go. So one thing about the metaverse is that everything is not just beautiful and viewable, but editable. So what I'm going to do right now is I'm going to bring this window hopefully up again. Everything that you're seeing here, oh shoot, come on. Tool window. Ryan, can you edit that for me? Watch the background. So what Ryan's doing right now is what I was trying to do, which is bring up a little edit window where he's basically going to delete the sky. There you go. And then what I can do, let me do that, Ryan. The metaverse is also about shareable, it's about shared content. It's about building with each other to help us so that it can scale much more rapidly as we're all able to contribute content to it. We've got a marketplace. This little window is a live window that lets you actually add things to your own server, as we're going to touch on later. So let me basically pick a different skybox here and click on it. And in a couple of seconds here, boom. Not only can I do that, but I could do something in the scene like add a tree. I go back to the beginning of my marketplace here. I got a little bush here. And there it is, and I'm standing in it. So we've already got a system up and running that allows you to bring content into it, share content with each other. The metaverse is also about the content itself being open standardized formats, so we can get as much, like we did with the web, we can get everything into it. So high fidelity, as I'll mention multiple times, is all open source, but today we already support things like FBX, OBJ. Our friends from Mixamo, their avatar creator out there, is something that you can do today. So these are standard file formats and a marketplace system that allows everybody to exchange content with each other. The next thing about the metaverse that I really would encourage you to think about, it's so fascinating. You know, all this new technology has come out, and we're all wondering excitedly, you know, coming to conferences like this, where does it all lead? You know, what is this going to look like? You know, today we've got all these amazing, you know, DK2 demos that we're downloading off the, you know, the Oculus store. We are, let me turn off one little feature there. I'm doing a little debugging on my avatars that I don't need to do. We're all trying out all these amazing apps. We're imagining a bunch of games that are going to come out. But what's really going to be where are we going to spend the lion's share of our time? If you look back at the early internet, when the internet came out, when the consumer internet really became powerful, about 1995, you had AOL and CompuServe. What was different? Why did the internet so eclipse AOL and CompuServe? I'll tell you why. It was the hyperlink. This is interesting. There's this phenomenon called Metcalfe's law, right, which says that the utility of a bunch of stuff will go up as the square of the number of connections between the stuff. It's a fascinating idea. And that's exactly what happened with the early internet. The web pages of the early internet didn't look that good, but they were hyperlinked to each other. And what that meant was that the utility of those pages went up and up and up because they could refer to each other. And that's what drove it. And so an interesting question is, if we are going to start sort of putting on these head-mounted displays and going into the metaverse or going somewhere, the place that we're going to go the most is the place with the most utility. And we believe that what's going to happen is we're going to, if we can build a metaverse in which our spaces that we create are linked together, or whoever successfully does that, those combined spaces with those hyperlinks will rapidly dominate everything in terms of our total usage. So what does the hyperlink look like? We're playing with it. This telephone booth right here, I'm going to go through, I'm going to walk through it, and when I walk through it, I'm going to instantly jump from this server to another internet server, which is another one of our alpha users, a guy that does live music. And so now it's connecting to that machine. This is a bunch of guitars that he's got sitting outside. This is going to come up in a second here. There's a show listing. This is actually a server that's set up in such a way. This is a pretty impressive demo. Over my phone, you just saw me live download all that stuff to my machine because the way this guy has his content set up, the way he's set up his servers, I'll touch on that in a second, it actually has to download everything every time. So here's the live music that this guy's playing over the next few days. That's the little theater where he does his music. And this is a pretty pretty awesome example of what people are already starting to do with the alpha version of high fidelity. So where is this server running? Well, the other thing about the metaverse, we believe, is that in the metaverse, you're going to run your own servers. We can talk about this for a lot of different reasons, but technology is now, the internet is now fast enough to allow us to run our servers from home. And there are 1,000 times more machines, 1,000 times more machines connected to the internet at home with great bandwidth now, 33 megabits per second on average in the United States. Then there are 1,000 times more machines at home than there are in all the hosting centers in the world. So this stuff's going to run on our machines at home. This music server is running on a guy's machine at home. There's probably 40 or 50 servers that are running in high fidelity already on people's machines at home since we started up a couple weeks ago, as TipTap pointed out. So let me break for a second and show you how easy that is to do. So what you'll find on the download site for high fidelity is two pieces of software. One is the client that I'm running. It's called the interface client. The other one is this little thing called the Stack Manager. The Stack Manager is the server. You download it, and you start it up, and you've got a virtual reality server up and running. And I want to show you how easy that is to do. So I'm not going to re-download it, but it's a quick download, about 50 megabytes. You start it up, it comes up on your machine. You see a screen like this. I'm going to stop the server for a second. You start up your server machine. You can give it a name. This server's name is Capri, which is the name of one of my kids. That your name is like DNS in the metaverse. That's something we need as well. You need unique names so that you can find everybody's servers, so that you can use names against them in the same way that we use names for websites. So part of what we've built at High Fidelity is this ability to find things by name. The other thing you can do to get started is just pick a bunch of content that you just like to kind of start with and then jump in there and start editing it with your friends and working on it to create your own space. We've been hard at work building those content sets, and I want to show you a new one. It's called Dojo. We're actually super excited about the Vive headsets and hand controllers, so we're kind of anticipating that, and we're building a little sort of test fighting area that we're having fun getting ready for that hardware when it comes out in the next few weeks. So it's telling me that this new content set has been downloaded and it's updated. My system restarts automatically. So now I can tell my friends Ryan and Chris to open their address bar and go to the place called Capri. And I do that by just hitting enter, typing in Capri like I would in a web browser. And with a little luck, what we're actually doing now, and they're doing it, and this is why they're sitting here, because the show network wouldn't let us do this, so they're nearby. They're actually connecting to my machine live, which is actually hosting them. So that's pretty cool. That's how easy it is to bring this thing up and get it running. And there's Ryan. And with a little luck here.
Hello, hello. Here I am on Philip's server. You can see my face being tracked by the 2D camera on my laptop. The light's not great in here, so the tracking's not that great, but you can get a general sense of the latency.
So as we've been talking about for a couple of years, the metaverse is about presence. What is going to make us enter these shared spaces is each other. The internet, the metaverse, real spaces in the real world are nothing if not a space between people. So our ability to feel the presence of each other and to talk to each other and to express ourselves, to emote, is critical to this next phase of evolution. And so for the last 2 years, we've been working on this, building different kinds of avatars and building both 2D, 3D cameras and HMD approaches to creating, hang on guys, Chris, can you say hi?
Hi, how's it going? Hi everyone. On the Oculus, can you hear me okay?
Yeah, we're a little cool there, but talk to us again, Chris.
Hey everyone, how you going? I'm here on as a robot with the Rift on.
So what you can see that's cool about this is we've got people in the head. We've got Ryan sitting in front of a PC moving his head. We've got Chris sitting with the HMD. They're both able to talk to each other, and we have the latency low enough. And you can't try this unless you're up here, or you're one of them. But you can try it at our booth. We have the latency low enough that you can feel each other. You can nod when the other person stops talking. You don't cut each other off, or you can interrupt each other in mid-sentence. That all works because you have to get the delay between each of us down to less than about 100 milliseconds, about 1/10 of a second. We've tested that across a bunch of different scenarios. ways of talking, video, no video, audio. What we've found, others have found, is that the magic happens at about 100 milliseconds. And the internet got fast enough to do that, to send our images to each other, to send our facial expressions and our voices in less than 100 milliseconds just a couple of years ago. So it's amazing that we've come so far so quickly. We've gotten to a point where we have enough internet speed to potentially create the kind of experience that we're creating here. And so, part of why we started the company about 2 years ago, as we did, was that we saw these network latencies coming down. And as I touched on earlier, these network latencies are that low, say 30 milliseconds across the United States. So we still got 70 to play with, basically, in our software. They're that low even between our machines at home, even when we're using a machine at home as a server. And so that's incredible. But and I want to show you a little more stuff. In fact, latency matters not just for the face-to-face experience that you're seeing from Ryan and Chris here, but it also matters for interaction, for physics, for game experiences. Again, that latency has to be very tight for us to be able to really play and have fun in there together. So with that, why don't you guys fly off and I'll meet you over at the dojo. The other thing about, I'm going to fly up into the air here, the other thing about the metaverse is it's got to be big. We don't believe in spaces that aren't like what we know. We value and we find real those things that resemble the waking experiences we've had all our lives. And I'm a fundamental believer, starting from back in Second Life and now with High Fidelity, that you've got to be able to embed massive amounts of content, chaos. Your friend building next to you and building something different. You have to build the systems in the metaverse that enable that kind of creative adjacency and reuse and sheer scale to work. So this is an example of a pretty big space that is running just on my one server. As I'll touch on a little bit later, another key part of our approach that we don't have up and running yet, but we have a great architecture for and little pieces up and running, is that we're going to start not only using our own machines to serve our own virtual spaces, we're going to actually use each other's machines to help us stream the data from our own servers to other people. Another important part of what we think is required to get to this idea of the metaverse. But first, let me show you some fun games. This is one we're really proud of. We're going to try this with these. We're on this, literally on this ad hoc wireless network, so we'll show you. But we've been working with the Bullet physics engine. High Fidelity is entirely open source. And part of what's amazing, so we've been working on this amazing demo that you're about to see here. This is pretty cool. So I'm going to sit and be the umpire here, and Chris and Ryan are going to give a try at playing a little air hockey for you. Now, while they set up and do that, and we don't walk yet, so never mind Ryan's stiff legs. They're both holding right now with their mice. There's a little bit of jittering, and we're still working on that. Some of that is still bugs in our system, but what you can see is that air hockey puck is colliding with the table. They're able to hit it at each other. And back at our home network, this is a bad situation we've got set up here, but the best we could do. On a home network, trying this out, it is 60 frames per second. We are running a 60 frame per second physics simulation on each of their two machines. We are doing some really cool work we're deploying some really cool stuff that we've done on the algorithm side to sort of make the two simulations look the same and have a sort of a server in between that is the authoritative place. That's why I can actually see what they're doing as they play. But it's pretty cool. Our goal over the next couple of weeks is to get this simple sort of air hockey experience to a point where it is absolutely playable. It is fast and fun. It'll work with the hand controllers when they come out. That are coming out with things like the Vive and several other amazing products that are out there today. We believe that you can do physics, you can do game-like interactions, the light coming on when they score and that puck dropping from the air when one of them scores is an example of a piece of interaction. So not only is the physics engine running, but we've written a little bit of JavaScript. I didn't touch on this before. Everything from that button on the UI that I hit there to the code on the puck, to even the clothes people are wearing can be completely automated with JavaScript. Again, we're trying to use the most open, widespread languages and systems that we can possibly use. Let me show you another game that's just a kind of a fun ultimate tour de force of a physics engine. This is really this really may not work. Here's everybody's favorite game, and this is pretty awesome. So I'll start. We know how this works, right? on stage, the idiot CEO will attempt to, while demoing, I'm going to turn that sucker around, right? I'm still in. So, Chris, you want to try one?
Well, right after you.
Now, this is totally being simulated. All these planks are sitting on each other right now, which we'll see in just a moment. And Chris survives. Mr. Ryan. Now, just to make it fun for you and give us time to show you more crazy stuff, I'm going to go next, and it's going to be a big fail. And there you go. Still some glitches there. Thank you. Still some glitches there, but I mean, we are able to really play with this. You can see me lifting that piece up. I can throw it at Chris there. One of my favorite things is throwing dice. Let's make a lot of them. You can see if I grab these guys and move them around, you hear that sound of them colliding into each other. That sound is being generated at the moment each one of those edges of the dice collide with the table or the wood. And it is literally real in every sense of the word. It's being created and streamed in 3D audio to Ryan and Chris and myself at exactly the time that the sound is made. One of us is making the sound, in that case me, that is playing the sound from our computer. The audio system is that fast. Not only can we hear each other with this perfect one-on-one presence, but the virtual world, the metaverse content, will be able to just generically make incredible sounds like this. So great example of JavaScript interactivity in the audio subsystems. But that kind of latency and that kind of generic ability to create content, I mean, I think what you're going to be able to do. I mean, I just, as a physics lover, it's my background, I just sit and play. I mean, every day now I'm like, I can't bear not to, I don't want to be the boss at work. I want to sit and just program JavaScript and play with new things. But we think it's just going to be amazing. You know, we're going to have starter servers that just are full, you know, rooms full of games like this that you can bring your friends to and play 60 seconds after you ran that server. So that's another piece of the metaverse. Huge amounts of content, interactive content in physics. The last thing I want to show you is really cool. We've been thinking a lot about what the first really high impact applications of the metaverse will be, right? I mean, what is it? You know, a fair question. You know, a lot of us here are dreamers about the more distant future of virtual worlds, you know, being big and being so similar to the real world and such an amazing, you know, I guess, public utility for all of us. But the really appropriate practical question, you know, to an investor, for example, is why is anybody going to use this right now? You know, we're certainly going to have amazing video games that we can play with our Oculuses. Those are going to be great. What's going to happen first? I mean, certainly we're going to be able to just build and be creative and build spaces like this incredible space that we've just shown you. And the graphics are going to get better and better, and, you know, it's going to get more and more fun to build content. But how's it going to be used? We thought about that a lot. How many Ready Player One readers here? Like almost everybody, right? You remember one of the things you really focused on was that idea that you went to school. You went to school. You didn't go to school anymore. You went to school in this headset. One of the phenomena, I'm going to show you with Chris right now. One of the things we've really been fascinated by, we're 17 people now, and on Fridays we all meet in the world, and we talk to each other in world. And we have a mix of ways we get in. Some of us are in the Oculus. Some of us with 2D camera. Some of us are with the FaceShift 3D camera. You can see FaceShift out there. Great partners as well. One of the things we noticed when we had those meetings was that, and it was a very curious outcome, was that it wasn't just more fun for you to be wearing the Oculus in a company meeting. It totally is, you can imagine. I mean, it's a blast. You know, you can look around and see what your friend had just said, and it's an amazing experience. But what we noticed was, I noticed this first time when I wear the Oculus, when you wear the Oculus, we can't track your facial features. Yet, of course, there's going to be a wonderful, I think, Oculus, Hao Li's work on facial regression, which is, I think, going to be demonstrated at SIGGRAPH, shows kind of what we can do maybe with a boom-mounted camera. But right now, when you put the Oculus on in high fidelity, we can only see Chris's mouth move a little bit, you know, on that robot head. Nevertheless, what we learned was that when I took the Oculus off, what all my coworkers said to me was, it was so much better to have you wearing the Oculus. And yet they couldn't see my eyebrows raised, like you can see Brian's eyebrows raised. They couldn't see the rich facial expressions that we can capture with these camera devices. Why is that? And I think it relates to this thing about teaching. The reason is that when I talked to somebody, I looked right at them. And because the HMD is mounted to my head, I always, when you're in the HMD and you're in a shared space, like high fidelity, you always look right at the other person. And that engages you with them in this magical way. And a lot of people have written about this, but teaching has something to do with that. We learn best when we are in a space where we are, in fact, able to look at, question, collaborate with each other. There's something magical to that. So in that regard, we started a project a few months ago. Ryan has been managing it at work. It's just incredible, where we sort of asked the question, what sample content can we build in high fidelity that we can start playing with this year, even with the DK2s that are out and anticipating the HTC developer version and getting all this stuff working? What content could we build that would be a teaching experience in high fidelity? And I want to show you that next. It's not ready yet. But Ryan was kind enough to let us take a look at it. So I brought up my address bar here, and I'm going to a server and a location. Again, this is just like the web. Cell School. And if with a little luck, let me just jump there and take a look at that. So where are we right now? Oh, I think I crashed. That was only the first crash. That's really pretty good for alpha software. Hang on, I think I'm going to be somewhere else now. But oh, here we go. Hang on. Let me try again. So what Ryan and his team have been building is the inside of a human cell. You can see the movement of the objects. It isn't done yet, but this is a single high-fidelity simulator which can be run on a single laptop like I just did. This one's running somewhere else. I don't know where. I think the team that's working on it. You can see these little guys here walking along the line. This is a really good simulation of what the inside of a human cell looks like. And we're going to build a classroom in there, and we're going to get real teachers and get them to start teaching real kids high school biology about the cell inside, with HMDs on, inside high fidelity. And I mean, if you look at this, I mean, I don't know about you, but I have a physics background, but when I saw this, I just can't believe how cool this is. I mean, talk about how not memorable cell biology is. Well, imagine what it'll be like after you spend an hour with these scary things chasing you around. And this is just after a couple of weeks of work. This thing's going to be a fully operational cell. You'll be able to go and pass through the ion channels and go inside the nucleus and see, you know, RNA making proteins or whatever. Actually, I think I said that wrong. RNA transcribing. But these pathways here are cytosine. I think cytosine, is that right, Ryan? Cytosine? We don't know what it is. They're those little monsters walking along are things I can actually click on one and ride on it here. Now I'm getting taken for a ride through the cell to somewhere else. I mean, if you're a kid in school and you can do that, and your teacher can walk up to you and look you in the eye and ask you, you know, whether you understood what you just saw, how could that change education? We're going to, and again, the metaverse has to be open. We're going to take this content that we're building here, and we're going to make it open like Wikipedia. So not only is this going to be this amazing, you know, cell biology experience, we're going to make it open so that high school teachers that want to use high fidelity, which costs nothing, you just deploy the servers, are the ways we make money are outside of that. A teacher can deploy a high fidelity server. They can do that today. They can put this content on it as soon as Ryan has it ready, and they can start teaching their kids in it and exploring that. I personally believe that what we're going to discover about how education can be done in the HMD is really fascinating, and so we're trying to build the right platform to back that up, to support it. So, you know, that's another thing about the metaverse. And another point to be made, I think is likely to be true, is whatever the metaverse is going to be, it's got to be open source. It seems unlikely, given how many large-scale structures we've built with open source in the internet today, it seems unlikely that the metaverse, whatever this sort of giant shared linkable space is, it seems unlikely that it's not going to be open source software. And so our approach at High Fidelity has been to do everything in open source in anticipation of that, and try to get, and we already have people making commits to our code base, helping us, and you can help us today. You can go to GitHub and jump in and check it out and build it yourself and run it. That's been true since the day we started. So open source is another critical thing. Final thought, how big can the metaverse be? I mean, we see the inside of a cell here, but how big are we really talking about? Well, as I said before, they're actually somewhere between, they're somewhere in the range of 500 million broadband connected desktop PCs today on the internet. How many is that? Well, if you look at these average connectivity rates I mentioned, 10 megabits up and about 30 megabits down. I think 10 megabits is about the worldwide average, actually, about the same as the US. What does that mean? Well, it means that if everybody was running a high-fidelity server, and those servers were sharing resources with each other, which I touched on earlier, they can't today, but they will be able to in the coming months. What it means is that we could collectively create a space whose literal scale, in terms of its sheer size and the amount of stuff you found inside it, was comparable to the landmass of the surface of Earth. And in fact, if we do the networking correctly, and we let everybody run their own servers, like I said, we'd have enough concurrent bandwidth from those machines to provide a megabit or two, which is what you're seeing right here, probably a little less with this demo, with what we've been doing here in my phone, to provide a megabit or two of streaming low latency access to every person now living on the surface of planet Earth. That is to say, each of those machines can handle about 10 or 12 people at the same time. And that is what you can do today with high fidelity. So today it is true that if we were using an internet scale architecture to simulate a virtual world, to simulate the metaverse, the scale of that world would be sufficient to stream content and create an experience like what I'm showing you right here to everybody now alive at the same time. And that, in conclusion, is where I think we're going. And thank you very much. It's been great to show you this. Thank you for letting us do it. I don't know if we have questions. Let's take some questions. I'm sorry, the lights are super bright. Maybe you guys could bring them down a little bit now. I can barely see everybody.
Hi, my name is Liesl Capra. I just want to qualify myself as an AI geek. We were an early player in Second Life. We had avatars running around, actually puppeted by AI. I won a NASA deal in Second Life, and my company was acquired last year. I'm really fascinated with what you guys are doing here, and what I really wanted to hear from you in particular is I'm kind of struggling with the way we're trying to transpose old metaphors into the new world that's coming. We're taking a physical world and modeling it. Yes, it's bigger and better. You were talking earlier about hyperlinks and how they really shifted our perception of how we can access information. And we're also seeing a lot of people taking the app metaphor and trying to pop it into VR. It works on a mobile phone, which is a sensor effector device, and we're trying to push that in. So I just wanted to really tease out your thinking a little bit. I mean, obviously, it seems like you're taking the approach of being able to model an infinite world in the metaverse, but what if your metaverse is not the one? How's this going to play out? What are your thoughts on that? Is that a bit vague? Do you get what I'm trying to reach?
What if our
at?
metaverse is not the one? You mean what are the most generic sort of iconography we are going to build around these things?
Yeah, so I suppose what I'm reaching at is that the web shifted how we accessed information and extrapolated ourselves, and it was hyperlinks. The web page was a kind of a metaphor for a physical object, and you guys were world building and giving people the tools to world build Second Life, and then we did apps. Well, what's next?
Yeah, let me answer it. That's a good question. Let me give you the best answer I can from human cognition that I can think of. One is that I think there are two extremes, and we're basically exploring both of them. The first extreme is text. If you think about text, it's our most compact list of symbols. We have so effectively used text, like in text messaging. We've dropped to this asynchronous text messaging to replace telephone calls for to a large part. I think the reason for that is that text is the tersest symbol set that we as shared humans in our communication can use. So there's a lot of stuff we do with text. So I think the @ keyword, the very idea of Capri, as I took you to, or cell science being a word that you can remember and type as a way of going to places, is fundamental and will remain in our systems because we're going to continue to use that. Even if we're saying those letters or something, it's the tersest form. At the other extreme, though, I think we are likely to build 3D spaces that are very reminiscent of places that we've already been and contain symbols we already know how to use, semantic symbols we already know how to use. One of the remarkable things about Second Life was that I always thought at the beginning that people would build that Second Life would be all like imaginary worlds and hypersurfaces and fractal geometries and stuff, and it wasn't. It was lots of Second Life was basically like Malibu and the French Riviera. And the reason for that, which I hadn't realized until I really thought more about why why it was happening, was that those are the symbols and the objects which we know best. And so we use them because they have the most power. A Lamborghini or a Ferrari is more meaningful to us than a land speeder from Star Wars because the former is a more commonly encountered symbol. And so I think that we're likely to build virtual worlds using the semantics of the real world to a large extent, at least first. And so my prediction would be over the next, say, 10 years, that we're going to build virtual spaces which are very lifelike because we are so comfortable using those metaphors. Look at using your finger on the touchpad on these mobile devices. That's incredibly better than the mouse. Why? Because we're not that smart. Like, it lets us do what we really wanted to do, which was just touch the thing there and move it and slide it. We've taken that stuff up. The closer we can get those symbols to our brain, to our standard operating behavior that we encounter when we wake up and live in the real world, the more effective I think these systems are. That's a partial answer. We can chat more about that later. Yes, sir.
So, congratulations on how far you guys have made it. I think this is groundbreaking and very cutting edge. Yesterday, someone had asked about virtual gaming spaces, and they asked the panel yesterday with Lucky and a few others how far away we were from being able to sit and play poker with 5 or 6 friends from around the country. Yeah. And they were kind of like, oh, when that moment happens, we've jumped the shark. I think it's interesting that you've now demonstrated that you've jumped that shark. Kudos.
And anybody here can build that poker game for us. I'd love to have it.
Right. So then, I guess I'll segue into what my question was. That was more of a kudos.
Thank you.
Obviously, in Second Life, you had Linden. What will the currency be for the metaverse? And will people be able to charge admission to the worlds that they create or their servers?
Yeah.
And then the second question is just more of a technical one, but with the distributive architecture nature of the network that you're building, will you use some sort of optimization or like if you find that there's a path that is quicker to get to a server for content than my ISP that I'm connected to, will you use hops to get the information to me, or would it, do you understand the nature of the question? Okay.
We will attempt to add value as a service provider, as a layer above the network of everybody's machines by doing that kind of probing to try to find out what. So when you need an additional server because too many people have come into your room, which is exactly the problem we need to solve, more than about 15 people in your room, so to speak, in your virtual world in this cell, is going to overload your home machine. But we can help you because we can find somebody else in your city whose machine is sitting there dormant, and then we can basically share that machine. What we're going to try to do is looking top down at the network to try to do the best job of finding that person for you. Again, all our stuff is open source, so you won't have to use our services, but hopefully if we do a good job of providing them, we can be very successful as a company. That relates to your earlier question, which is about the currency. What I think is going to happen here, a little bit different than Second Life, is I think the currency, the shared value of the metaverse on something open source like High Fidelity can grow even faster than Second Life did because what we're going to do is probably create a currency around shared compute time. So I think the baseline currency, now whether that currency is the Bitcoin or a different, a blockchain-based currency or some sort of a currency that we create, whatever, that I'm not quite sure about yet. We're still thinking about that. But what we do know is that by contributing our machines to each other, we can create a baseline value for that currency, which people can then use to buy and sell content from each other or buy and sell access to spaces. And I think content, by the way, is the more likely from what we saw in Second Life, but before like tickets to go into a space. But that's a minor point. But I think that the thing that's going to be really interesting is that we can create some kind of an open currency that's essentially valued in compute time. And I didn't touch on that yet here, but that's been one of the pieces of our architecture and one of the places we think we can do something of use for everybody that is using this open source software as we go forward.
Yeah, I love that. I was part of an Interstellar project for decoding.
Oh, yep,
yeah,
sure.
Okay, so
it's
you're
great.
right. Thank you for your answer.
Yep, sure. Anybody else?
Yes, sir. So absolutely fantastic tour de force of innovations. So many wonderful things to comment on. Yeah, absolutely.
Thanks.
And I'm very, very confident that this is going to go very, very far. At least the open source stuff, and I'm really intrigued by that. And it sounds like you're doing a great job to try to provide value on top of that. Can you talk just more about what your vision is for kind of this new DNS system?
Yeah.
I've been thinking a lot of that we need a new World Wide Web, basically. Yep. This looks like it could be it.
Yep.
And then also I would say that I'm very interested in, so I've won hackathon awards for visualizing like Wikipedia and providing interactive, immersive experiences in that. I'd love to build something on top of this. Where do I start? How do I?
Come and talk to us just after this, for sure, and
Okay.
we can give you whatever advice we can on that and give you the resources.
And the distributed architecture, I mean, that was like, I was like, whoa, you know, we're just reinventing the internet right now. Let's just do it.
So what we're doing with DNS, just to touch on that for a moment, you're exactly right. What we're trying to build is a usable DNS system for the next generation. That's what we're doing. It's place name system. What we call it place names. There's already hundreds of them that have been bought. We actually already sell them, even though we're in alpha, because you wouldn't, otherwise everybody would name squat them just like DNS. So we're actually happily making a little bit of money today from just the fact that there's no other fair way to distribute place names. So today, Capri, I own that place name. I just showed you that one. I own various other cool ones that you might imagine I would own. But we all laugh around the offices at the, amassing our empires of popular single word place names. We're selling those. What we basically do, what I think DNS2 looks like, which I think we're providing a reasonable example of. And again, certainly other people can copy us. Maybe there'll be multiple systems, but I think like DNS, there'll only be one or a couple of root servers. And we hope we can do that and make a little money on it. We charge $20 a year for the place names today, so just like DNS. What the place name does is it basically doesn't just identify your server as an IP address. It actually finds it and tunnels to it. So the thing that we're doing that's really cool is I just brought up Capri on the network here over my iPhone. What our DNS system does is the moment I brought that machine online, it talked to our home server, which would be like DNS root. And we don't have the cascaded hierarchy of retransmission for efficient caching of the results yet, but we don't need that. We're tiny. That'll be easy to build. The DNS, the server at home basically found that machine and port number, and we'll give it to you. So when Chris and Ryan typed in Capri, they basically did a DNS hostname lookup. We responded with the current IP and port address. This is a meaningful thing because we need to do this with, and we're using all open protocols for that. We're using the stun protocol to discover the machines. We're using OAuth for identity. I didn't even touch on that, but you can come by and ask more about it at the booth. But that's our vision for it, that we can basically push up something that allows you to associate a place name. And then we have a whole pathing system within the local servers. You saw me do that a little bit with /cell school. And we're doing that as well. So we think that the basic DNS structure combined with network probing and tunneling to actually get you to the machine within seconds. So if I take this machine, close it, go back out to the booth, go to a coffee shop and open it up again, Capri will be up and running in like 15 seconds. It'll be routed.
Beautiful. Yeah, and I'll just kind of, for your own benefit, add on top of it. You're saying Metaverse, the World Wide Web being a subset of the Metaverse, and you started to try to show like your demo online, basically.
Yeah, the slides.
Are you using like WebVR for that, or what are you?
We are using the web engine that's built into Qt right now, which is Chromium. Is that right? Did I get that right?
Okay.
We're using Chromium in open source. We're using Qt as our a bunch of its features, networking and some of the graphics layers. So
yeah, I'm just getting exposed to WebVR too, so I'm trying to figure out how the whole ecosystem's evolving with the future looks like. So great, thank you very much.
Do we have time for any more, Tiptat, or anybody? Anybody else? Final question? Nothing? Yes?
So there's already an open source hybrid OpenSim Metaverse out there that
Mm-hmm.
people are generating on their own server and their own OpenSim. Is there any chance of that network being able to integrate with
Sure. And of course, I'm well aware of it. OpenSim is great, and that was one of the proudest, moments to see OpenSim kind of show up inside as an adjunct to Second Life. Yeah, absolutely. We have tried to attack some of the hard interaction and interactive content problems, starting ground up, because we believe that to get to 90 frames per second on the HMD and 60 frames per second for the physics simulation, we needed to rewrite all the systems that underlay Second Life, for example. So we started anew. That said, we should be able to interconnect to OpenSim in a way. I think, well, we're not there yet, but we're not there yet. I mean, Second Life and OpenSim have an awesome feature set, and it's huge. I'm pretty proud of it. We're not all the way to being a superset of that system yet, but I think that we're getting there, and I bet we'll get open source submissions, and I'd love to have them from those teams to better interconnect with us. We'd be, delighted and honored to have those interconnections made. Again, though, I think getting to everybody's machines at home and indexing them and naming them and everything and getting them shared with each other, it's this opportunity to take us literally 3 to 4 orders of magnitude beyond where we are today, which is really going to be shocking in terms of the appeal, because already Second Life, for those who don't know, Second Life's 40,000 servers today, but they're hosted servers in co-location facilities. They comprise a landmass about the size of the LA basin, and they host right now access to probably like 80,000 people right now concurrently. But again, as I'm saying, if we do our work right here and we get to your machines at home, and that tunneling and protocol routing that I just discussed is something that OpenSIM, for example, does not do. It's hard to get that connected up. We wanted to really solve that problem. Minecraft doesn't do it either. We wanted to really effectively, be done with this problem. If we get that working and we get access to all those machines, then we get to this literally 3 or 4 orders of magnitude larger than where we are now. So, I mean, that's what that's what gets me up every morning, is to say, imagine how cool that'll be. So, great. Thank you very much, everybody. Thanks for coming. Appreciate it. Showing your demo.